All right, so for part A, it wants to know how many miles did Chloe travel from 0 to 2. So basically what we're given is a piecewise defined function that represents her velocity. So to go from velocity to distance, we need to integrate because we want to take away a unit. So we're going to find the integral of c of t dt. And since part A says from 0 to 2, we're going to find the integral of 0 to 2. So the integral from 0 to 2 would be the top part of the piecewise. So it'd be from 0 to 2 of t e to the 4 minus t squared dt. So this is a u sub. So you'd have to say u equals 4 minus t squared. The derivative of u would be negative 2 dt. There's no negative 2 here, so we'd divide by that. So you get negative 1/2 du equals t dt. And then we'd come over here and say, okay, this is negative 1/2 the integral from 0 to 2 of e to the u du. And then we'd flip our bounds to be in terms of u. So you'd find u of 0, which is 4, and u of 2, which would be 0. So you'd have negative 1/2 the integral from 4 to 0 of e of u du. But then to make this logical, you'd get rid of the negative and say, okay, that's the same as 1/2 the integral from 0 to 4 of e of u du. And then we know that the antiderivative of e to the u is simply e to the u. And we'd evaluate from 4 to 0 all over 2. So you'd get e to the 4 minus e to the 0 all over 2. And anything to the 0 power is 1. So we'd get that this is the same as 1/2 e to the 4 minus 1/2. And our units would be in miles, and that would be representative of the distance from 0 to 2. Okay, part B says at time t equal 3, is Chloe's speed increasing or decreasing? So if we want to know if the original function is increasing or decreasing, we look at the derivative and we talk about if the derivative is positive or negative. So we would want to find c prime of 3. So c prime of 3 would really be the same as finding the table value at 3. So that would be like finding, in this case, c of 3, because this represents velocity. And we want to know if speed is increasing. So we need to know if velocity is positive or negative. So c of 3 would be 12 minus 3 times 3 minus 3 squared. So this is 9. This is 9. 12 minus 9 is going to be a negative. And then we need to know if c prime of 3 is positive or negative, because that represents acceleration. So c prime of t at 3 would be negative 3 minus 2t, which would be negative 3 minus 2 times 3. So that would be a negative 6, negative. So this is a negative. If velocity and acceleration are both negative, then our speed is increasing because velocity and acceleration have the same sign. So speed is increasing because acceleration and velocity are both negative at t equals 3. Part C, is there a time t from 0 to 4 at which Brandon's acceleration is equal to 2.5 miles per hour. So one of our favorite theorems, MVT, we want to know, is his acceleration equal to 2.5? So what we're going to do is say b of 4 minus b of 0 all over 4 minus 0 and see if that equals 2.5. So b of 4 minus b of 0 is like 11 minus 1 all over 4 minus 0. So you get 10 over 4, which is in fact 2.5. So because b is differentiable and continuous from 0 to 4, and the slope of the secant is 2.5 on the interval 0 to 4, by MVT, there must be a time c in which his velocity would equal 2.5. miles per hour. Part D. Part D asks us, is there a time at which Brandon's velocity is equal to Chloe's velocity? So now in part D, we want to know, okay, does B ever equal C? So essentially what we're trying to do is say that B of t is equal to C of t. So basically what we're going to do is set up some sort of equation where we could say, okay, does B of 0 minus C of 0, equal some number, where we can use the intermediate value theorem. So basically what we're going to do is we're going to show that B of t minus C of t is equal to a number above and a number below. So let me go up to my data. And B of 0 is equal to 1. C of 0 would be equal to 0. So basically, B of 0 minus C of 0 would be equal to 1, which is positive. And then what we're going to do is find B of 2, which is equal to 1.5, and C of 2, which would be equal to 2. So then you have 1.5 minus 2, which is negative 0.5, which is negative. So if we have a positive and we have a negative, for B of t and C of t to be equal, then essentially we would want it to be equal to 0, meaning they hit each other, right? Point of intersection. So since this is positive and that is negative, then for some time t between 0 and 2, b of t would equal c of t.